Hi guys, let's have a look at some revision questions on the subject of continuous random variables, which falls under the area of study of probability. Okay, now I'm going to assume that this is tech free for some of it and tech enabled for other parts of it. Okay, and I'll just do the commentary on which way we're treating it as we go. Okay, alright, now we've got the time taken to complete a task in hours is random variable x. That's a continuous random variable x with probability density function as follows. This funny looking thing here looks like a quadratic-y thing, a linear thing there, and 0 everywhere else. Fairly typical for a continuous distribution, and this is the probability density function. Alright, now c is a constant apparently. So we've got to find the value of c firstly, then we've got to sketch the graph of the distribution. We've got to write down the most likely time taken to complete the task. That sounds to me like the most probable, which would be the mode, wouldn't it? Would be. And then we've got to find the probability that the time taken to complete the task will be more than 0.8 hours and between 0.4 and 0.8 hours. Now at this point, guys, I want you to pause the video and have a go at this question and then come back when you're ready. Otherwise you won't learn as much from then watching me do it. Okay, so off you go. Okay, you're back. Alright, here we go. This is my attempt. Part A, off we go. Find the value of c. Well, the area under a probability density function has to equal 1, doesn't it? So therefore we can form that equation there where the area under the first bit from 0 to 0.6 plus the area of the second bit from 0.6 to 1 must equal 1. Yes, and we've just got to solve that for c. Okay, now I've done it on the CAS there and I've got this value here. Now that's quite fair enough, and that's what you would do in an exam setting. But if you were required to give an exact answer, because remember there's no mention in here about to 4 decimal places or anything like that, and in our system if you're not asked about decimal places you have to give an exact answer. So the question is, what are you going to do? This is a rational number because you can see the repeating 4 there. That indicates that it is a rational number, so it can be expressed in exact form. So let's have another go at it, okay? I'll show you. Yes, that's right, it's a rational number. And if we go over the screen and we have another go at it, where I'm basically putting these terminals of the integrals, not as decimals, but as fractions, see that? It comes out in an entirely different way, with c is 25 over 36. So there's your answer. Now, my TI CAS handheld calculator, which is the one that we use at my school, I usually have the calculation mode in the settings area under auto mode. So if you forced it to be exact mode, you might get this answer more easily, but I got the decimal first, and then I just rewrote the whole thing with fractions instead of decimals in these in the terminals for the integrals, and I got the answer that I needed, 25 over 36, guys. Okay, that's the first bit. Now, part B, this is part B. I've sketched the thing on the CAS now. Okay, so there it is. Looks pretty weird, but the area under this thing is 1. So I sketched this as a hybrid or piecewise function, okay, and made this function, f48 of x is this function, a hybrid or piecewise function with, that's the conditional sign there, with c equal to 25 over 36, and that's what I got, okay? There you go, so that's got that bit of it done. Now what's part C? Write down the most likely time taken to complete the task. Alright, that's going to be the mood. And what's part D while we're at it? The probability, find the probability that the time taken to complete the task will be more than 0.8 hours, and secondly between 0.4 and 0.8 hours. Okay, let's do C first, alright? The most likely time taken to complete the task. Well, can you see what it is from the graph? Well, the most likely, most probable time to complete the task is actually 0.6 hours. It's the x variable here at the peak of the graph. Okay, there it is, 0.6. Done deal, guys. That's it. Now let's do part D. The probability that the time taken to complete the task will be more than 0.8 hours. Now I did try to do this one in a non CAS manner. I tried to work it out by hand, okay? So if you assume you're in an exam 1 setting, which is a technology-free exam, this is the way you would do it. So the probability that x is greater than 0.8 would be the integral from 0.8 to 1 of this thing here. Now we're putting our value of c in here, you'll notice. Now, is that going to be easy to work out? Well, I think the 9 cancels. Yes, that's right. 25 over 4. And I've made that 4/5, and I've made that 1 just to make it easier on my head while I'm doing the analysing that definite integral. Yes? So let's go a step further. That makes sense to me. What about you? Very good. Now we're going to substitute our values in, and we're just going to plug and chug then. Okay, there's that's with 1 substituted in. That's with 4/5 substituted in. And where is that going to get us? Besides to the moon or somewhere. That's just a half. That's going to be, okay, 5 4s are 20 minus 8 over all over 25, isn't it? So yes, that's going to be that. Now, we've got a lowest common multiple, this beastie. So I guess we make 50 the lowest common multiple for that. So we're going to get an 1/8. Ooh, it's an 1/8 is the answer, guys. Now the next one, I'm here to warn you, worked out considerably worse. But it's a great thing for you to do, just to give yourself some confidence in doing things by hand, because I know that the examiners are not very impressed with students' by hand skills. So, you know, all the more practice for you to get good at it. So here it comes. Now just be prepared for a shock. It is not very nice. Very easy to do on the CAS. But here comes the hand done version. So it looks like it's from 2/5, that's 0.4, to 3/5 for this particular function, that's the 0.6 bit, and then from 3/5 to 4/5, aka 0.6 to 0.8 for this part of it. Okay, now I've got to basically do a lot of plug and chug now after I integrate. So, does that work out right? Yeah, goodness. Yes, that's 2 into 10 goes 5, 2 into 36 goes 18, 5 times 25 is 125, that's right. So that's just cleaning up a bit, and that's already as is on the previous line. So let's go another step further now. Okay, I've integrated now. I've integrated and I've put the 1/3 of x cubed, I've put the 1/3 down there. Now what have I done over here? Yeah, that's alright. That's just the integral of 1 minus x is x minus x squared over 2 from there to there. Alright, now let's, okay, lots of plug and chug now, guys. Get ready. Ooh. Well, I think you just better believe me that that's what you get. This one here is with 3/5. Yeah, that's right, and that's with 2/5. Now this is the second thing here. All the rest of this line relates to that second term there in the square brackets. So we've got 25 over 4 times 4/5 minus 8 over 25 minus 25 over 4 times 3/5 minus 9 over 50. It's a mess, isn't it? I told you. But I did persist and I did get the answer out in the end. So 125 over 54 times, goodness, 19 over 125, that's alright, plus 25 over 4. Now, what have I done there? That's first term gets you, yeah, that gets you 12 over 25. Those two grouped together under an LCM get you this, and these two grouped under an LCM get you this. Okay, so, okay, next line. That cancels nicely, doesn't it? It's beautiful. So therefore you get that. That's after you group these under an LCM of 50, you get that. It's still a mess, still a big mess. Okay, that goes with that, and you get that. Okay, so now what are we supposed to do now? Alright, the LCM, believe it or not, guys, we get that. Okay, we get that, and we get that. Now, I think there's a bit of cancellation throughout the nation now. We could cancel the top and the bottom by 2. Yes, very good. And what do we get? You madman, wolfman. It's 157 over 216. Well, my goodness, that's what I call hand working with a difference, isn't it? Now we're going to go over the screen and do it the CAS version, and it's just going to be like falling off a log. Using CAS, there she be, guys. Look at that. Okay, so here's a PS for you. Now, if we were asked to find the mean of this continuous random variable x, how would we do that, guys? Can you remember? Well, it's the expected value of x, which is also called mu, which is the integral of x times f of x with respect to x from 0 to 1. Okay, that's what you do for the expected value, and there it is on CAS. Please don't forget the x times f of x with respect to x from 0 to 1, and you get this beastie here. Now you can see that definitely is a rational number because there's a repeating 6 there. Okay, so that's yes, that's what you get. Now to 4 decimal places, that's how you would express that. Now, if you want to get an exact value, just in case you do need to get an exact value, I tried a few different techniques and it wasn't working. So I pulled a rabbit out of a hat, and I basically found this for you, which I already kind of knew about. You go to the menu, this is in the TI CAS handheld, you go to the menu, then you go number, then you go approximate to fraction, then you hit enter. But you make sure firstly that your calculation accuracy setting is in just float, okay, not float 2 or 4 or 5 or 6, just float, to get the maximum decimal accuracy you possibly can for your approximate version. And then you go from that version and you select what I just said. You select approximate to fraction. This is the default of something or other which I don't understand, and you get this value here, 71 over 120. There's your exact rational answer, guys. So can you please, if you are using a TI CAS handheld device, please keep that in mind, approximate to fraction from the menu and then the number option, right, in your menu system. Okay, here's another PS, that's postscript. If you were asked to find the median, do you know what to do? Yes, it's from 0 to m of f of x with respect to x gets you 0.5, and you have to solve for that on your CAS, yeah? So there it is, da-da-da-da. Now, oh, that didn't solve, that did it. Oh, goodness. So I tried to solve. Remember, this is a hybrid or piecewise function, so apparently it doesn't like it. It's not going to solve it for me. It's getting stubborn. Okay, so I've got to try plan B now. So what would that be? Well, what I eventually did was, I thought, well, I'll first just analyse what the area under the curve is from 0 to 0.6 for the first part of the hybrid or piecewise function. And then I thought, well, once I get that value, then I'll just basically find the area of the residual bit, the required amount of area of the second part of the hybrid function. So for example, this from 0 to 0.6 got me a probability, a total area of say 0.3. Then I would just then solve for the integral of the second part of the hybrid function from say 0.6 to m, from 0.6 say to m equals 0.2, you know, to get me a total of 0.5. But I didn't have to, because I actually found that the area under this thing from 0 to 0.6 was exactly 0.5. So that was rather neat, wasn't it? And confirmed it from the other end. So therefore the median is basically 0.6. There it is. Yeah? Postscript. To find the variance, okay, while we're at it, the variance of x is the expected value of x squared minus the expected value of x all squared. So I did that on the CAS for you. There it is. Yes, you've got to forget, you're not allowed to forget that that's an x squared in there, that's an x in there, and then the whole thing is squared. Alright? Now with CAS over the screen we go. Look at that. What a beautiful sight. So there's your expected value of x squared minus the expected value of x all squared, and you get that, right? So that's a sausage machine of numbers. If you want to do that to 4 decimals, you would get there 0.0313 to 4 decimal places. So that's the variance. Now what about, you know what's coming now, don't you? Postscript of the standard deviation, and that is truly the end. That's just the square root of the variance, guys. So if you do that on CAS, you just do that. So therefore the standard deviation would be 0.1768 to full decimal places. There you go, and you're a star, huzzah, etc. So I hope that helped you. That's some revision work in the area of continuous random variables, okay? Alright, well, we look forward to seeing you next time. All the best to you, and we'll see you later.